And today there is no such theory. Today we will be discussing about all the questions which were previously asked, no matter it is from which chapter or what it is. Just a second, I guess I am not getting your comments. Let me check. Yeah, so we are live here and welcome to Exampur. Let's start with the questions which were asked in the previous year part from the physics. So yes, without any delay, let's start with the inventions. So inventions are the common one which are asked in the examination. So the first question is from the basic invention. Let's see who all can give this answer. So yes, the first question is, who discovered television? Now, it's a very basic question, but it is asked in the examination. This was asked in CGL 2017. If I'll talk about television, so who was he? We are aware of, if I'll talk about the TV, so he was J.L. Baird, that is John Baird, right? Let's move forward with the next question from CGL. And the next question is again from the discovery part, that is the invention. Who actually invented dynamite? Now this question is important because it's not only about CGL 2017, but apart from this particular year, this question has been asked in other examinations as well. So what all are those examinations? They include different SSC examinations, railways, many examinations are there in which the same question is asked. So please remember, if I talk about the discovery of dynamite, who was he? He was none other than Alfred Nobel. So Alfred Nobel was the one who has actually discovered dynamite, or I'll say invented, because I have already told you about the discovery and invention. There are two different things. If I'll talk about invention, it is there for the first time. If I'll talk about the discovery, it was already there, but after some sort of experiments and all, this thing came into the existence. So okay, actually existence into a mind, it was already existing. Okay, so if I'll talk about the invention of dynamite, it was discovered by Alfred Nobel. Next, the boiling point of water depends upon dash. Now this is from CGL 2016. What is the correct answer? Boiling point of water is dependent upon dash. Now same question can be tweaked. How? The question may be asked, if I'll talk about mountains, here if cooking is done, what? If we cook food over here, I'll talk about rice. So rice are not cooked in the proper manner. Why? There's a reason behind it. So both the equations are linked with each other, but I want answer from everyone. What is the answer? Is that particular issue atmospheric pressure, or is it volume, density, or mass? What is the thing? So yes, please remember, whenever I'll talk about the cooking of food, so if I'll talk about mountains, because of the atmospheric pressure, actually there is the lack of atmospheric pressure or less atmospheric pressure. So what happens? Because of that, boiling point actually decreases. That is, if I talk about the cooking of rice, before reaching 100 degrees centigrade itself, it is actually cooked, because of which we feel that it is still raw. Fine. So here the correct answer is going to be atmospheric pressure. Please remember, the boiling point of water actually depends on the atmospheric pressure. There is no such condition of volume, density, or mass over here. So Anjali has given answer A, and Anjali, you are absolutely correct, totally correct. Next question is, for which of the following game players must have the knowledge of Pascal's law? This is from CGL 2017. Again, this question can be tweaked. How? If I'll talk about Pascal law, we must be aware of, if I'm taking an example of a spherical ball, if I just put a pin over here and I just put pins on these locations, if I'll press this particular location, that is, if I put pressure at this location, there would be equal amount of pressure exerted over these locations as well, right? So this is actually the Pascal law. So we have Ankit here, and Ankit has also given the answer A. So Ankit, if I'll talk about this question, I guess I'm getting your comments quite late. If I'll talk about this question, for which of the following game players must have the knowledge of Pascal's law? So what would be the correct answer? Is it climbing? Is it paragliding? Is it rafting? Or is it scuba diving? So let me tell you about these games. For the climbing part, you can talk about hills. Fine. If I'll talk about paragliding, we are jumping from the cliff or the hill and using those parachutes and all, that is paragliding. If I'll talk about rafting, in the rivers we use those particular structures in which we actually sit with our friends, or we are actually enjoying, or we are doing the adventure on the river stream, or we can talk about any of the water body. But if I'll talk about scuba diving, within water we get into the water, where we can talk about the deep, or diving, where you can talk about the sea or the ocean. So yes, if I'll talk about this scuba diving, that is, we are going inside the water, and at this location we must be aware of the pressure. If I'll go into the depth, the pressure is going to increase, right? So for this scuba diving, we must have the knowledge of Pascal's law. Got my point? So yes, Ankit, absolutely correct. Anjali, I'm waiting for your answer as well. And everyone who has joined the session, kindly please give me answers so that we can start interacting. Totally correct. If I talk about scuba diving, so here we must be aware of, if I talk about this water, underwater, till the depth, there would be some depth, isn't it? For let's say it's D depth. So if I'm going underwater, the pressure is going to increase. Because of the same reason, if I talk about a dam, the dam's wall actually is made thicker as soon as we reach deeper. Why? Because we know that more the depth, more the pressure. So Anjali, Ankit, both of you are correct here. The correct answer would be scuba diving. Next, which of the following force is a virtual force? This is from Cgl 2013. Which among us the following force is a virtual force? Is it centripetal? Is it centripetal reaction force? Is it centrifugal, or is it nuclear force? What is the correct answer? And everyone who is there in the session, kindly like it and share it, so that we can have lots of conversation and we'll be clearing up all our doubts, whatever are there. So yes, if I'll talk about the force which is virtual in nature, or rather I can write one more thing over here. If I'm talking about virtual force, I can talk about pseudo force, right? So pseudo force or virtual force is one and the same thing. I'll explain that, but before that I want the answer. So what do you think? What is the correct answer? Centripetal force, centripetal reaction force, centrifugal force, or strong nuclear force? What is the correct answer over here? And everyone is requested to kindly answer this. Virtual force. See, if I talk about the centrifugal force, this is actually the correct answer, that is the virtual force. Now what is it? Anjali has given answer, sir, it would be strong nuclear force. No Anjali, the correct answer would be centrifugal force. Why? Let us understand about this. See, whenever we talk about a force that is acting towards the center, any of the force that is acting towards the center, that is considered as centripetal force, or I'll say centripetal force is a force that actually tends to go inwards, that is towards the center. But if I talk about centrifugal force is the force that is actually moving away from the center. Now you can take the example, when MotoGP race, you would have seen that MotoGP races, right? So whenever the driver actually rides his bike, he actually tends to bend inwards, right? Why? So that he doesn't skid, correct? So this is the reason why he is actually bending. So this is the example of centripetal force. But this centrifugal force is actually not the real force, it is actually pseudo force, which is acting, or it seems to act outwards from the center, that is outside the center. So there's a trick also which I gave last time. If you are from the Hindi medium, you can just relate it. So just have a look at this word, petal. So what I gave the example last time, no, Ankit, you are wrong here. If I talk about the outwards force, for example, if I'm talking about the washing machine, there you will be considering this fugal part, fine. So please remember this point. See, I'll give you a hint, I'll give you a trick here. In Hindi, I'll give you an example. How many of you from Hindi board, can you just tell me, so that I can use Hindi term right here, because this channel is actually for the English medium candidates. If you are from Hindi medium, I'll give just example, fine. So I would just want to know who is from Hindi medium right now, so that I can actually relate it. Okay, so this was the part. Next, here centrifugal was the correct answer. Next, the motion of the wheel of a bullock cart while moving on the road is an example of dash. Now this is from Cgl 2014. What kind of motion is it? No issues, Ankit, no issues. It's good that you have given the answer, and I'm sure you will be correct over there. So Anjali, you are from Hindi medium, na? Ankit, are you from Hindi medium, or you can understand those Hindi terms? If you can understand, I'll just get back to the question and explain that part. Then I'll come to this part. So if you want the explanation, let me tell you. See, what we can do, if I talk about centripetal force, I'm writing for you. If I talk about centripetal force, so in Hindi, if I talk about this petal word, just try to relate it with the word pitti pitti of a mother. बचपन में क्या होता था कि मम्मी ना पिटाई लगा के कहती थी, बेटा तुम सेंटर में आ जाओगे, right? What she does? Actually at that time, she used to beat us and used to say, बेटा तुम सेंटर में आ जाओगे, right? So just try to relate that word. पीट कर कहाँ आ जाओगे? Center में, towards the center. So it is a force. Actually that thappad was also a force, right? So that thappad was force, and here also peetna word you can relate it. So centripetal is a force which will actually act towards the center. So यहाँ से you can relate it. Now if we talk about the washing machine, Washing machine is doing what? When it is washing the cloth, you must have seen, I'll give you the example, when we are talking about the washing machine, there's a bag that is kept in this side, right? So why those bags are kept? Those bags are so that whatever dust particles or whatever particles are there, they can actually come into that. So this means what? Whenever this washing machine is rotating, so this means it must be acting, those force must be acting outwards, right? So here, if I talk about these particular things, that is whatever is washed into the washing machine, those particles get stuck into this part. That means force is acting outwards, right? So this outward force would be what? Centrifugal force. As simple as that. But please remember, this is actually the pseudo force or false force. Pseudo force. No issues, Anjali, it is good that if you will be there in this channel, you will be able to understand English also along with your Hindi part. Okay. So, okay, let's get back to a question. The motion of a wheel of a bullock cart while moving on the road is an example of dash. So, what kind of motion is it? Yes, waiting for the answer, everyone. The motion of a wheel. See, when a wheel is rotating, this means it will be taking your cart towards this direction. When it is taking your cart to this direction, this means there's a translatory motion. That is, there's a motion in the straightforward direction. But apart from that, this wheel is also rotating. This means there is rotation also. So rotation motion can be related with rotatory. And if I talk about this motion, this is what? This is translatory. So do we have this translatory and rotatory? Yes. So we have translatory, that is motion in the straight direction, and rotatory, that is there is the rotation. So Anjali, Ankit, please remember here option C would be correct answer. So I guess you can relate it now. Fine. Let's move forward with the next question. Next question is, what principle or law explains the working of hydraulic brakes in the automobiles? This is from SSC Cgl 1997. Quite older version, but yes, after 97 also it has been asked many times. So answer please. What principle or law explains the working of hydraulic brakes in automobiles? So is it Bernoulli's law, Poiseuille's law or Poiseuille's principle, then Pascal's law or Archimedes' principle? What is the correct answer over here? Answer please. So is it Bernoulli's principle? What? Answer everyone. Waiting for the answer please. So we have discussed about this law earlier. Remember, when I was giving the example of that particular ball, that is, whenever force is exerted, it will be exerted towards every point. Similar kind of force would be there. In the same point, if I'll just put the example here, hydraulic brake, whenever we are using the brake in a cars or bike, we are using that brake. So by using that brake, we are getting the equal pressure on both the wheels or on all the four wheels, right? So here, the correct answer would be Pascal's law. That is option number C. Next question. Which of the following waves cannot be polarized? So answer please, then I'll explain this part. What is this polarization actually? So yes, answer please, and all of you who are not aware of this polarization effect, what is this polarization? I'll let you know. But answer please, and please let me know. What is polarization? Do you know this or not? This is from CGL again, from 2016. Which of the following waves cannot be polarized? Is it radio wave, ultraviolet wave, or infrared or ultrasonic? What is the correct answer? Waiting for the answer please. See, whenever we are talking about polarization, this means here we can take the example of a light. Fine. And here we can talk about electromagnetic waves. Electromagnetic waves. Now, do you know, when I talk about these electromagnetic waves, there is the combination of both. That is, okay, Anjali has given the answer D and Ankit is with A over here. That is ultrasonic. Anjali, you are absolutely correct. Ankit, is your answer A or you are also going with D? So your answer is absolutely correct. Let me tell you, ultrasonic wave, you can actually relate it with the sound. Because in the sound, we understand there are several type of waves where we talk about the audible range, then there are several where we talk about the infrasonic, ultrasonic, right? So here, okay, Ankit, your answer is A, cool. But answer that is correct is actually D. Let me explain. So this is sound part. What I was saying, if I talk about light, this is electromagnetic waves. Now what happens? If there are two planes which are perpendicular to each other, like this, fine. So in this condition, what is going to happen? One of the wave is your relating with the electrical field. One of the wave is actually there in this condition, that is they are actually mutual perpendicular to each other. So that particular wave would be what? Magnetic. So magnetic and electro, so it is the combination of electromagnetic waves. Now what happens if I talk about a plane? If I talk about a plane, in that plane if I'll just try to mention this part, that is the wave part, so we can make it in the any direction, any of the direction. Now what happens if this light is actually passed? If light is actually passed, so it actually gets polarized and it is in the straight manner. That is, these waves come in the straight manner. So when I'm talking about the straight manner, so this is actually, here we can see that light is actually polarized. But in case it is not polarized, what can happen? If I make an analyzer over here and again this light is passed, and if I try to tilt this analyzer with certain angle, this here intensity will actually decrease. But if this is actually rotated with 90 degrees, none of the light will be able to pass from here. So yes, please remember, yes, you're right, Ankit. Anjali was correct over here. Only and only what is going to happen? Only electromagnetic waves can be polarized. And here, what we are talking about? Ultrasonic, that is sound waves. Sound waves cannot be polarized. That's why ultrasonic was actually the correct answer. That is option number D. Okay, let's move forward now. So before moving forward, let me tell you there's an Exampur official application which is having the live paid courses, free subject wise, topic wise quizzes. Then we have free examination wise PDF, practice at PDF, daily, weekly, monthly current affair. All these things at a single platform now. Where you can get it, just go to the Play Store, type Exampur over there, click on the install button, click on the open part, just do the registration and start using it. Okay, so there's the next question. Which of the following is not an electromagnetic wave? So we were just discussing about electromagnetic wave, right? So let's see who gives this answer. This is from Cgl 2016. Is it X-ray, gamma ray, cathode ray or infrared? What is the correct answer over here? Answer please. Electromagnetic waves, EM waves. So which is not an electromagnetic wave? Answer please. And everyone is requested to kindly answer so that we can go in depth with all these questions. Is it X-ray, gamma ray, cathode ray, infrared? What is the correct answer over here? Answer please. I guess I'm getting your comments quite later. So if I'll talk about electromagnetic waves, here we can talk about GXUVIMR, right? What is that? Gamma ray, X-ray, remember? So yes, Anjali is actually thinking, sir, is it D? That is infrared, okay? Study with Ankit. Ankit, your answer is actually pending. So can you give this answer please? And others who all are there in the session, kindly like it and please start giving answers. Ankit is going with B, that is gamma ray. Ankit, how it can be gamma ray? And Anjali, just try to link this part. G is standing for gamma ray itself. And Anjali has given the answer infrared, that is I standing for infrared, right? And what is left? If I talk about gamma ray, then there's a X-ray, which is second option as well. The only thing which is not present here is what? Cathode ray, right? So please try to link with this. Ankit, see, if you are going with gamma ray is already there in the category of EM waves, right? So here the correct answer would be cathode ray. Got my point? Whenever you are getting this question now, please remember the sequence order, GXUVIMR. Gamma ray, X-ray, infrared ray, fine. So yes, here cathode ray is actually not part of electromagnetic wave. It's as simple as that. Okay, so here option C was correct. Next, which phenomena do bats or dolphins use to find prey, predators or obstacles? What is the correct answer here? The phenomena which bats, dolphins use to find the prey, predators or the obstacles. What is the correct answer here? Phenomena used by bats or dolphins. You are aware of this prey, predators and all? We will be discussing this in the environmental science, where we must be aware of. If I talk about a cheetah or a tiger is actually dependent on some animal which he'll kill, right? So here we have prey, predator, that is one of the animal which is dependent on another. Anjali, these are actually the waves, that is GXUVIMR is actually the short form, which is G is representing gamma ray, X is representing X-ray, U is representing ultraviolet, I is representing infrared and so on. Fine. So GXUVIMR are the electromagnetic waves. You can use that sequence order so that in these options, whenever you are asked about the frequency, energy, you can easily click on the correct answer. Fine. Okay, let's get back to this question. Here the question is asked, which phenomena do bats and dolphins use to find prey, predators or the obstacles? Now what is obstacle? Whenever this bat actually flies, what happens? It releases these waves. Which particular waves? You have to give the answer. So they are doing what? When they are moving, they are actually releasing the waves, because of which, if obstacle is there, they actually because of the presence of obstacle, they come back and they get to know, okay, obstacle is there, and they accordingly change their path. So here, this process is known as echolation. What? Echolation. So here, if I'll talk about these four options, here option number D, that is echolation, is the correct answer. So yes, Ankit, here option number D will be correct. Please remember, whenever there's any bat, they are actually using the concept of sonar. That is what? Sound navigation and ranging, which is actually used by ships and all. So here the concept is actually dependent on echo, and for this echo we require a minimum distance. Do you know what is the minimum distance for this echo? I'll give you a hint. You would have actually tried this in your homes or on the hill station. Whenever we take name of ourselves standing at the hilltop, ever tried that? So Ankit, have you ever tried? You're standing on a hilltop and you're saying Ankit, and then the sound is again coming back, that Ankit, 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 something like that. So yes, if I talk about that part, that is actually what? That is the echo. Now for this echo, there must be a distance minimum of 17 meters. What if this distance is greater than that? We'll be having that discussion again. But till here, is there any sort of doubt? If there is any doubt, please let me know. So yes, this is the part where bats and dolphins are using the echolation process in order to find the prey, predators or the obstacles. So is it clear, everyone? Is there any sort of doubt that is left? What is echo? What is sonar? How they are actually using this concept? Is everything clear till now? So Anjali, Ankit and all the others which are actually live here, waiting for the comments. Is everything clear till now? If there is any doubt, please let me know. Till then, I'll have water. Everyone. If it is clear, then we'll move forward with the next question. Next question is, what is the minimum distance required to hear an echo? We have just discussed about echo, right? It was the repetition of the sound. Okay, need that explanation once again? Okay, I'll be explaining that once again. But Ankit, please give this answer. I have just told you this answer. And Anjali, I guess you can give this answer right now. Answer please. What is the minimum distance required to hear an echo? So I'll give you the example of a song right now and explain this part. So Anjali is with C, and that's great, Anjali. Totally correct. The correct answer is 17 meter. So you can do one thing. Just after this class, just have a look at one of the song, and that's in Hindi. Yeah, Ankit, your answer is also correct. So there's a song that is तेरे चेहरे में वो जादू है. Just try to listen that song. तेरे चेहरे में वो जादू है, तेरी ओर खिंचा जाता हूँ. It's something like that. So in this starting of this song itself, he takes the name of his girlfriend, I guess, that is Reshma. So he just shouts Reshma, and that sound is actually repeated back. Reshma, 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 and it's like that. So you can even try your boyfriend's or girlfriend's name just standing at the hilltop. But the condition is that distance must be all minimum 17 meters, because for this echo 17 meter minimum distance is required. Now let me explain this part. Here's a boy who is standing here and he's trying to speak something, and here's a hilltop or a cliff, whatever it is. Minimum distance is of 17 meter, right? So okay, let's start. For example, he speaks Reshma, and you might say, sir, he might have a boyfriend also. Yeah, right now those particular things are also possible, and it's totally cool. So if a boy is shouting boy's name, that's also cool. So you can take the name of anyone, whatever you feel like. So once Reshma, he shouts, what is happening? Because of that particular distance or those particular conditions, when everything is matched, because there are some conditions also of this distance. Apart from that, there are atmospheric conditions also. So this sound is actually repeated back. Fine. So this is the condition which is known as echolation. That is, we can talk about echo over here, echo. But what will happen if I'll consider another example? Now we are in a room where I am explaining you any of the concept, and we are in a classroom. Now there is no such hill station, there is nothing. What if I speak something and that sound is again repeated back. See, both the conditions are different. In the first condition, when we were talking about this Reshma and all, that was near the hilltop. Now I'm talking about we are in the classroom, I'm taking a class and whatever I'm saying, that sound is again coming back. For example, I'm saying, Ankit, why are you not studying? So this sound is again coming back in the room. So do you know what is this condition known as? This condition is not known as echo now. Please remember, this condition is not echo, this condition is reverberation. Both the things are different. That Reshma, Reshma, Reshma on the hilltop was echo. Fine. But this example where I am talking about a classroom, where I am discussing something and my sound is actually repeated, but it is actually in the form of damped vibration. That is, it is actually decreasing. So that is reverberation. There's a difference in both the things. Now there's a question. If I talk about movie halls, or you can talk about cinema halls, in these cinema halls, why that particular area in which we are sitting is actually made in such a manner that we can talk about those curved parts. Apart from that, if I talk about the seats, they are actually cushioned. So what is the use of those parts? That is the cushioned seats. If I talk about the room also, you will try to just tap on the wall. It's not directly wall. There's some layer which is present on the wall as well. So that cushion is also there on the wall. Why is it so? It is because whatever sound is coming from that particular actor or actresses, we need to listen that in the proper manner. So whatever noise is there, whatever extra sound is there, it is actually absorbed. Fine. So in the room also, if you want that your sound should not be repeated, what you can do? You can put cushions over there, you can use those curtains, that is in Hindi we call those pardas and all. That will do what? They will actually absorb the sound. Fine. So this is the reason why in movie halls we have those cushioned seats and all. No doubt, cushioned seat is actually for our comfort also. But apart from that, it is absorbing sound as well. Okay. So here 17 meters is the correct answer. Next, supersonic airplane creates a shock wave which is known as what? This is from Cgl 2012. Who can give this answer? The question is, supersonic airplane creates a shock wave called what? So is it transition wave, ultrasound wave, sonic boom or transverse? What is the correct answer here? I need answer from everyone. And yes, if there is any sort of doubt, please let me know. Answer please. Question is, supersonic plane creates a shock wave called what? And this is from Cgl 2012. Let's see who all can clear Cgl 2012 right now. Ankit, Anjali, others need answer. Supersonic airplane creates a shock wave called what? When we are talking about these supersonic airplanes, please remember, if I talk about this sonic boom, that is where Mach number is present. According to those Mach numbers, we understand, okay, what kind of sound is it? So it is actually compared with the speed of sound. Okay, so here, if I talk about the supersonic airplane, they create a shock wave which is known as sonic booms. That's why we say that ultrasonic waves, right? So sonic boom, it can be related with that. And the number which is present, that is known as Mach number. And according to this Mach number, we can actually relate what is the intensity of that particular sound. Okay, so here option number C is the correct answer. Next, a bomb explodes on the moon. You will hear its sound on the earth after how many minutes? This is from Cgl 2016. So Anjali was the one who has given the correct answer for the previous question. Awesome, Anjali. Great. So Ankit, you are also with C with the previous question. If yes, that was totally correct. If no, then you can just rectify yourself. But talking about this question, if I talk about a bomb that is exploding on the moon, you are going to hear this sound on the earth after how many minutes? So is it 20 minutes, 2 hours, 20 minutes, 3.7 hours, or you can't hear it? Options please. Sorry, answer please. Everyone, require the answer from everyone. Until I guess I'm getting your comments quite late. Can you just refresh it so that I can get real-time comments? Yes. See, if a bomb is exploding on the moon, do you seriously think you can receive that sound? No. Reason behind it is, if I'll talk about moon, there is no such atmosphere. That is, there is no such medium. Because of the lack of medium, since there is no such medium, so there is no such concept of sound traveling. Because, Anjali, after 20 minutes, we can't hear that sound. It's not possible. Why? Because if I talk about moon, there is no such layer present on the moon, there is no such atmosphere. That is, I can talk about there is no such medium. When medium is not there, that means sound cannot travel. Sound cannot travel through vacuum. Fine. So this is the correct answer. That is option D. You cannot hear the sound of that particular explosion. Anjali, I think you get this point, right? Okay. Next. Sun appears red in color during sunrise and sunset due to what? This is from Cgl 2016, and everyone who is there in this session, kindly give me this answer. And yes, everyone is requested to kindly like it and share it. Yes, answer please. Sun appears red in color during sunrise and sunset. So there must be some reason, right? What is that reason? Reason behind sun being red during sunrise and sunset. What's the reason? This is from Cgl 2016. There are 4 options. What is the correct answer? The fact that sun emits only red color at that time. Second, red light have longer wavelength and scatters away. Third, sun comes out from the mountains. The fact that all the colors scatter away except the red. So Anjali is here with option A. Others, are you all with option A? I want answer from everyone so that I can explain this part easily. See, if I'll talk about this part, I'll write Vibgyor. And Anjali, for your sake, you are asking about GXUVIMR. Let me tell you, this is again a sequence order of the colors. That is violet, indigo, blue, green, yellow, orange, red. In this manner, if I'll go, what is going to happen? Wavelength will increase. Remember, wavelength increases in this direction and scattering actually decreases. What will happen? Scattering will decrease. So there's the least scattering of red color. Because of this, what happens? Whenever we are talking about this sunrise and sunset, in this condition, what is happening? Only this red color, since it is scattering the least, is actually seen by us. All the other colors are actually scattered. Because here the scattering level is actually going back in this direction. This is least scattered and violet is the maximum scattered. So other colors actually get scattered and this red color is not scattered. Fine. So this is the part. Totally correct. Option number D will be correct answer here. Right. Next. The color of the ocean appears to be blue because the sunlight falling on it is dash. Is it reflected, refracted, diffracted or scattered? What is the correct answer? We have just explained this part, right? So yes, you can explain it now with that same concept. So what is the correct answer here? The color of the ocean appears to be blue because of the sunlight falling on it is dash. Ankit, Anjali, others, what is the answer? The color of the ocean appears to be blue because of, is it reflected, refracted, diffracted or scattering? There must be some reason, right? So first of all, let me tell you what is scattering. In atmosphere, there are particles which are present. When sunlight actually strikes it, colors are there. We have already discussed about Vibgyor, where if I talk about the maximum scattering, it is in this condition. That is violet, indigo, blue. These will scatter the most. And because of the scattering, we can see that the color which appears of the sky is actually blue, right? So here, Anjali is with option D and you are absolutely correct. That concept is actually scattering and here we can say that scattered would be the correct answer. So the color of the ocean appears to be blue because the sunlight falling on it is scattered. Next. Rainbows are formed when sunlight dash. This is from Cgl 2015. What is the correct answer? Rainbows are formed when? When rainbow is actually formed. So yes, answer. When it is incident on raindrops hanging in the atmosphere is dispersed after suffering refraction. Incident on raindrops hanging in the atmosphere is dispersed after suffering refraction and internal reflection. Incident on raindrops hanging in the atmosphere is dispensed after suffering reflection, or none of the option is correct. So yes, answer please. And everyone who is there in the session, I want answer from everyone. Please. Answer please. See, we'll talk about this reflection, diffraction. Let me explain this part. But before that, I want the answer from everyone. Only then I'll explain. Yeah. No one? Okay. So I'll explain this part now. Before giving the answer, let me tell you what is this reflection. Reflection. This can be easily understood. Whenever we are talking about any of the surface, that is, we can talk about a mirror. Fine. Now what happens? If a ray of light is coming from one of the medium, it is striking this part. There must be some point where it is striking. And this incident ray is actually coming back or going back into the same medium. Anjali is with option C. Okay, I'll just tell that. But before that, let me see. This is incident ray. So this angle which is here is angle of incidence. This is angle of reflection because this is reflected ray. This is actually the condition of reflection in which light coming from the medium goes back into the same medium. As here, light was coming from air, it is getting back into the air. Fine, this is reflection. What about refraction? In the refraction, medium changes. This is air, for example, this is water. And here we have a fish. If I try to have a look at this fish, this incident ray will not be in the straight direction. What will happen? It will either bend towards the normal or go away from the normal. That is, medium is actually changing here, right? So this is refraction. Now what happens? This is angle of incidence. If this angle is greater than critical angle, then the light suffers total internal reflection, and in spite of going here, it actually goes parallel in this direction. This is TIR. So for the raindrop, same concept is happening. In the raindrop, when the sunlight is coming, it enters it, that is, medium is changing, right? Apart from that, inside it, we have internal reflection also. So the same question was actually asked here. Rainbows are formed when sunlight is what? So here it is incident on the raindrops hanging in the atmosphere is dispersed after suffering refraction and internal reflection. Got my point? Refraction is there. Why? Because medium changed. Which medium was there? One was air, then droplet was of water. So air, water, medium change, that is refraction was there. And if I talk about internal reflection, total internal reflection, we will say that angle of incidence was greater than critical angle. The same logic is applicable in the diamond also. Diamond shines because of what? Total internal reflection. Fine. In the similar manner, mirage is formed because of what? Total internal reflection. Optical fiber works on which principle? Total internal reflection. So these are the things. Okay. So yes, option number B will be correct here. Next. Which of the following color of light deviates least through the prism? I have just explained this part, right? So waiting for the answer. Let's see who can give this answer. I am talking about the least deviation. So what is the correct answer here? Which of the following color of light deviates least through the prism? What will be the correct answer? Yellow, green, violet, right? We have discussed all these things earlier. Even today we have discussed, if I talk about Vibgyor, on moving from left to right, what we have discussed? The scattering power or scattering concept will decrease, right? So this means red is the light which will scatter the least. So in this manner we can say that the color which will deviate the least will be what? Red color. As simple as that. Got my point? So yes, here option number D is going to be the correct answer. And one more point which I have to tell you, if I am going in this direction, wavelength is going to increase and scattering will decrease. And in a similar manner, vice versa will happen if I am going from red to violet. Is this point clear, everyone? If this is clear, please give me thumbs up and let me know that this is clear. Okay, so this was the correct answer, that is option number D. Next, so we have Exampur official application here, which is one-stop solution for the government job aspirants. We have live paid courses with the test series. We have free subject-wise and topic-wise quizzes with the report card. Then we have job alert, admit card, and examination date. All examination previous year PDFs with the solution. Then we have free All India scholarship test with the report card. We have topic-wise free live classes. We have free full length and sectional tests with the report card. Free exam-wise PDFs and practice set PDF. Then if I talk about current affair, we have daily, weekly, monthly current affairs and unlimited subject-wise practice set questions. All these at a single platform. You can just go to the Play Store, type Exampur there, click on the install button, click on the open part, just register it and start using it. Okay, let's get back to our questions. Vehicles use dash to see the objects coming from behind. This is from Cgl 2016. Which particular type of lens or mirror is used here? So let's see who gives the correct answer. Answer please, need answer from everyone. Question is, vehicles use dash to see the objects coming from behind. Ankit, I am waiting for your answer from such a long time. Busy somewhere? Yes, Anjali, your answer please. Vehicles use dash to see the objects coming from behind. So is it concave lens, convex lens, concave mirror or convex mirror? So Anjali is with C here. Okay, cool. So Anjali is saying, sir, it would be concave mirror. But Anjali, let me tell you, whenever we are talking about concave mirror and another mirror is convex mirror. I have a trick here and it is very, very helpful. Just have a look. if I talk about the number of letters which are there in the concave, this is the trick actually, because I know in the examination it creates confusion which is the correct answer. Just have a look at the numbers. 1, 2, 3, 4, 5, 6, 7. How many digits are there? 7. If I talk about convex, how many digits are there? 1, 2, 3, 4, 5, 6. How many digits? 6. Now the trick which is going to be applicable in the examination is 7 letters is always greater than 6. We are aware of that. This means it is going to create a larger image. Please remember this part. Very simple to understand, very easy. Same logic happens in Hindi as well. Avtal darpan, uttal darpan. Uttal is having lesser numbers, but avtal is having more numbers. Convex 6, that is lesser one. So it will create smaller image as it is lesser than 7, right? Now, whenever we are there in our car, we are there in our bike, we are using a side mirror. Now, side mirror must do what? Should it create a larger image or should it create a smaller image? Obviously, when we are talking about the whole road, that whole road, then there are trucks, buses, those all things must come in this part, right? So what do we want? We want a smaller image, correct? So for a smaller image, we'll do what? We'll use convex lens. Very good, Ankit. Totally correct. If I talk about the larger image, we'll use what? Concave. Now just have a look at the question. Vehicles use dash to see the objects coming from behind. So if I want to see the objects coming from behind, those bigger objects in this manner, so what I'll do? I'll use convex mirror. So absolutely correct, Ankit. Here we have option number D, that is convex, as the correct answer. So got my point, and this trick is actually applicable everywhere. So please remember. Fine. Okay, so option D was correct here. Next. Tesla is the unit of magnetic field dash. This is from Cgl 2014. Is it induction, moment, area or flow? So Tesla is the unit of what? Magnetic field, induction, moment, area or flow. What is the correct answer here? So Anjali, Ankit, what is the correct answer here? See, please remember, whenever we are talking about Tesla, here the correct answer is going to what? See, if I'll talk about the magnetic field, fine. So in this magnetic field, if I'll talk about magnetic induction, so here option number 8, that is magnetic field induction, would be the correct answer. So here, if I'll talk about Tesla, Tesla is actually the unit for measuring the magnetic field intensity, or we can talk about induction over there. Next. Certain substances loses their electrical resistance completely at super low temperature. Such substances are called what? So this is from Cgl 2014. Is it superconductor, semiconductor, dielectric or perfect conductor? Yes, Anjali, you are correct. Great. What about this question? Certain substances loses their electrical resistance completely at super low temperature. Such substances are known as what? So they are doing what? They are actually losing their resistance. Now just think. They are losing their resistance. This means what? Charge will start flowing, right? What is resistance? Resistance is actually the obstruction in the path. Now since we are talking about electricity, this means we are talking about the obstruction in the path of electrons, that is the charges, right? So yes, if resistance is there, electrons will not be allowed to move. This means electricity will not flow. If I'll remove this particular resistance, easily these electrons will start flowing, right? So in this condition, what we can say? We can say that lesser the obstruction or lesser the resistance, more is the flow of charge and more is the electric current. So here we can talk about the superconductors. Superconductors are the one which can easily allow the current to pass, right? So yes, superconductor is the correct answer in this scenario. Next, before moving forward, I have a question for you. Since we are talking about this electricity, my question is, if I talk about pure water, I am talking about pure water. Now this is asked in the examination. Please remember, again from Cgl part. If I am talking about pure water, so is it good conductor? Is it good conductor of electricity? Or it would be considered as the superconductor? Or it would be there as a insulator? It is considered as a insulator, or it can be in all the conditions. All of the above are the correct answer. So pure water is what? Is it superconductor, good conductor? Superconductor, good conductor, insulator or all? What is the correct answer? Now this is the important one because many of you must be thinking it in the wrong manner. Yeah, waiting for the answer please. Your answer? Yeah, answer please. Pure water is good conductor, superconductor, insulator or all. Now my point is, don't do this experiment at your home. There's a reason behind it, but before that I want answer from everyone. Anjali, can you answer this? And everyone who is there in the session right now, whether you're working somewhere or whatever you're doing right now, I want answer from everyone so that I can explain this part, because this actually creates the confusion in the examination. If I talk about this pure water, please remember pure water is actually insulator. It is not going to conduct the electricity, never. But now you must be thinking, okay sir, so winter season is coming, now what I'll do? I'll put the spring over there and I'll put my finger. Please do not do this experiment. Why? If I'll talk about the present scenario, water is not pure, fine, because there are some added salts and all. Because of that, water is not pure. Please do not conduct this experiment at your home. But yes, in the examination if it is asked, pure water is what? So it is insulated. That's absolutely correct. But how you will get to know that this is pure or not? That's why I'm saying please do not conduct this experiment by putting the finger and all. But yes, pure water is actually the insulator and it doesn't conduct the electricity. Okay, so yes, here we have next question. In the absence of Earth's atmosphere, sky would appear what? In the absence of atmosphere, in the absence of Earth's atmosphere, sky would appear what? Is it blue, deep red, white or black? What is the correct answer here? Answer please. I am asking, in the absence of the Earth's atmosphere, sky would appear what? Is it blue, deep red, white or black? Answer please. Kala libas. Yes, answer. You're just deleting the message, huh? Okay, so if I talk about this Earth's atmosphere, the correct answer is going to be black, because see, whenever there is no such color, the color which you can see is black, right? We in the physics part, if I talk about black, what is it? It is actually the absence of all the colors. But if I talk about white color is actually the combination of all the colors, where we have all the colors. Now you must be thinking, sir, what? How can white be combination of all the colors? Newton's ring experiment, I don't know how many of you have read about it. I'll just tell you, Newton's ring experiment consisted of what? There were several colors, and when that ring was actually rotated, the color which is seen with the eye is white. So white is actually the combination of all the colors. Fine, if we rotate that ring in which different colors are there, you will be getting white. So white is the combination of all the colors. But if I talk about the absence, you can talk about black. So yes, if there is no such Earth's atmosphere, the sky would actually appear black, because there will be no concept of scattering and all, right? Next, the solids which conduct the electricity at high temperature but not at low temperature are called what? This is from Cgl 2013 and this is from modern physics part. Answer please. This would be the last question for the day. Answer please. The solid which conducts the electricity at high temperature but not at low temperature, they are known as what? Are they superconductor, semiconductor, metallic conductor or insulator? Yes, answer please. If you will give this answer in the super fast manner, I can proceed with the next question as well. So yeah, if I talk about the solids which conducts the electricity at high temperatures but not at low temperatures, they are actually known as semiconductors. Now what all are its examples? If I talk about the examples which are the chipset features, if I talk about a laptop, some mobile phones, we have chips, right? So they are made up of what? There we talk about silicon, germanium. So all those examples are taken. So yes, if I talk about the semiconductors are going to be the correct answer over here. So option B is correct. Let's take one more question. Which one of the following is not a non-conventional source of energy? Now this question I asked day before yesterday also, right? So wrong answer was given. Let's check who can give the correct answer in the first go. Please remember, whenever I am talking about non-conventional sources, just have a look. See, renewable is non-conventional source, non-renewable is conventional source. So don't get confused. Many of us think what? Non-convection, non-renewable are the same thing. No. Renewable sources are non-conventional sources. So let's have a look. Which of the following is not a non-conventional source? Now this two not are actually creating confusion, right? So just have a look. Which of the following is not a renewable source? Is not a renewable sources. So we know about renewable source which can be renewed again and again. The example are solar energy, wind energy, tidal power. What is solar energy? Energy coming from the sun. Wind energy, energy obtained from the wind, where we can talk about windmills and all. If I talk about tidal power, you can talk about oceans and all, where tides are there, high rise of tide, low rise of tide. They are actually helping in the power generation. So what is going to happen with the tide? Nothing. It will always be there. What is going to happen with the wind? Nothing. It will always be there. What if I talk about solar energy? It will also be there. So the only thing which is there is your natural gas. So natural gas is not a renewable source of energy, right? So here option number B will be the correct answer. So these were the important previous year questions from the CGL part. Now from tomorrow we will be starting with the chemistry. Fine. In the morning again we will be having all the mixed question sessions with all the SSC examination. This was from the only CGL. In the morning tomorrow between 12 to 1 we will be having the previous year questions of all the SSC examinations between 12 to 1, and in the evening we will be starting with the chemistry part. Fine. So yes, this was all for today. Bye bye everyone. Please take care. And yes, I will meet tomorrow with the chemistry session. Bye bye. Please take care.